Alright, so we're going to continue on with 3.7, which is cost, income, and value problems. And these still involve charts, so hopefully it's on the same lines, but we're going to be dealing with more specific types of problems. Now, the three important formulas that can be used for these charts are cost, income, and total value problems. So let me just give you what they are. So the cost equation, cost equals the number of items, whatever items it is, times the price per item. Makes sense if I told you that it cost $5 for, I don't know, a bag of apples, then it'd be 5 times however many bags of apples you bought, which would be like, let's say you bought 5 bags. I don't know why. You're doing a Halloween party or something for popping for apples. I don't know. So then you multiply 5 times 5. Okay? Income. Income is the hours worked times the wage per hour. So that means like how much you make per hour. So if you're making $10 an hour and you work 10 hours, then you've got $100. Okay? So simple enough. Now, total value. Total value is the number of items times the value per item. Okay, and again, if the value of whatever item it is $7, 7 times however many you have, you multiply them. Again, cost and total value are very similar. Basically, same premise of the idea. Hopefully this starts coming to you naturally because it makes sense. But yeah, so we have that. Now, example 1, I already have the chart up there for you. It says tickets for the senior class play cost $6 for adults and $3 for students. A total of 846 tickets worth $3,846 were sold. How many student tickets were sold? Well, we know that it's the number of items times the cost equals the total cost. And I guess that would be really the cost number of items. That'd be like the price per item. My bad. Price per item. Which is like, again, which is kind of like the cost of an item. Okay, so how much does a student ticket cost? Student ticket costs $3 and an adult ticket costs $6, and now we need to know how many of each. Well, we know we're looking for how many student tickets, so if we make student tickets X, then if we find X, we find our answer. Now we need to figure out how many adult tickets. Well, we know that there's a total of 846 tickets that were sold. So if we took the total and subtracted how many students have student tickets we sold, the leftover will be the adult tickets. So that's why it's gonna be 846 minus X, because we have our total and we subtract the student tickets, and whatever's left over is our adult tickets. So now, again, how do we find these two? All we do is multiply across. So X times 3, which we'll say is 3X, and then I'm going to say 6, and then in parentheses, 846 minus X. Now, did it say that they're equal? No, it gives us a total cost. Okay, so if I know that if I add 3X and I add the adult tickets, which are 6 times 846 minus X, and that's going to equal our total cost of $3,846. So now we need to solve that. So I'm going to distribute. So 3X plus, and then that's going to be 5,076 minus 6X equals 3,846. I'm going to combine 3X minus 6X, which is negative 3X, plus this equals this. I'm going to subtract 5,076 on both sides, so I get negative 3X. And I'm going to get a negative 1,230 on both sides. Divide both sides by a negative 3 to get rid of that negative 3 in front of the X. So X is going to equal 410. So therefore, it says how many, if we go back here, it says how many student tickets were sold. We found X, and that's the student tickets. So there were 410 student tickets sold. Okay, So yes, these problems require a good bit of work, but doable. Alrighty, next one. Joe purchases 100 postage stamps worth $9.90. Half of them were 1-cent stamps, and the rest were 14-cent stamps and 22-cent stamps. How many 22 stamps did he buy? Well, we know that there was a total of 100, but we know that half of them were 1-cent stamps, so half of 100 is 50, okay? Now, what are we looking for? We're looking for 22-cent stamps. So it would make sense if we made this to be X, because as long as we find X, we found our answer. So we now know that if we already bought 50, these two have to add up to 50 right here. Okay? So I'm going to take 50 and I'm going to subtract X from that, and that will give me however many 14-cent stamps. Again, that makes sense because if I said I bought 10 22-cent stamps, 50 minus 10 is 40, so that means we would have 40 as this value right here. Now, if you still get confused on that, make sure you ask for help. Okay, value. Well, these are obvious. It's 1 cent, 14 cents, and 22 cents. We're gonna this time, before we used dollars instead of cents. Well, we're gonna use cents. Okay. And again, if you want to use the dollars, go for it. Just make sure everything's in the same unit. But now I'm going to multiply. So 50 times 1 is 50. And I'm going to have 14 times 50 minus X. And then I'm going to have 22X. And I know that my total value has to equal $9.90. But look, I put this as cents. So I have to change that to cents, which is 910 cents. Okay? So when I write my equation, I'm going to have 50 plus 14 times 50 minus X plus 22X, and that's going to equal 910 cents, which is, oh wait, I don't know why I said 910, that's 990, okay, oof, my bad. Good catch, Miss Robinson, got it. Okay. So now I'm going to solve, so 50 plus, and 14 times 50 is 700, minus 14X plus 22X equals 990. I'm going to do a couple combining. I'm going to combine these, and I'm going to combine these. So I'm going to get 750, and then I'm going to have 6, 7, 8 plus 8X equals 990. Subtract 750 from both sides, which will give me 8X equals 240. Divide by 8. So X equals 30, and it asks us how many 22-cent stamps did he buy. We know that X equals the number of 22-cent stamps, so he bought, gonna be all fancy on this one, he bought 30 22-cent stamps. There you go. There you have it.